So for this video, we're going to talk about some superclass things, and we're just going to basically expand on our um, teacher class, which inherits human. Felix the cat is with me here today. You may hear him meowing. So private fields in the superclass, we're going to make those, and in our class that we directly inherit from our child class, we're going to go ahead and make a bunch of those private because they just should be. Because it gives you encapsulation. It keeps your state separate from the client's space, so they can't mess with the state of your objects directly. You'll need accessors and mutators if you're going to do that, and you can use class invariants to make sure that client code doesn't do anything stupid. Private superclass methods. If you have a method in your superclass that your subclass or your child class can't access, what good is it? Well, it's good inside the superclass, so it might be a good idea to have. As your programs get more complex, you'll find that there might be reasons for that. Felix, knock it off. All right, so let's open back up these files. Human. It has an age. It can be handsome, charming, and has a hair color. A teacher inherits by extending human, and it can be good at Java and good at teaching or not. We created a constructor which sets the values of are you good at Java and are you good at teaching. It calls the superclass. Oh geez, I screwed this up. Oh no, I didn't. Well, yes, I did, actually, because this would make every teacher handsome, charming, and have gray hair. We don't want that. So the teacher constructor actually needs to have these variables passed into it, and then it just sends them up to the superclass constructor. So we have yeah, that was a mistake. Let's fix it now. Now we're going to call the superclass with these variables as the formal parameters. Well, they're not the formal parameters, are they? I can't remember. No, they're the actual parameters or the arguments. These are the arguments: handsome, charming, and hair. That's going to require us to change the way we call teacher from our client code. Our client code is new teacher, good at Java, good at teaching. We also need to add charming, handsome, and hair. Oh, we should do age too while we're here. Let's do age while we're here. All right. And then the argument or the parameter list here is going to get charming, handsome, hair, and age. We have to go back over here and here. All right. We can use the same name because we're in different variable scopes, so they can have the same name. They're not going to conflict. What is this barking about? Constructor human, boolean, boolean, string, boolean is undefined. Yes, it is, because we forgot to add age over here. We'll make it the age so it doesn't conflict. This is not important, but it just makes things easier. All right, so now we do have a constructor that takes 4 arguments. Boolean is handsome, Boolean is charming, string hair, and int the age. So then this constructor for teacher has to have all the things for teacher as well as for human. When it gets here, it calls the superclass with handsome, charming hair, and age, and then it sets the internal, it's still public at this point, fields to the values that are passed in. This should work. Oh, blows up. The constructor teacher boolean 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 string int is undefined. Is it? Constructor teacher boolean 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 1 2 3 4 string int is undefined. I just defined it. It's right here. What did I do wrong? 1 2 3 4 string. Oh, duh, integer. The compiler's never wrong. Don't get mad at it because it's always right. Okay, refers to the missing type integer. Constructor teacher refers to the missing type integer. What? Oh, because in databases they're called integers. In Java they're called int. Okay, so now everything works. Hopefully this makes some sense. We've created a constructor that gets a whole mess of arguments. Some are for the human and some are for the teacher. The ones that are for the human get passed up to the superclass constructor with this little confabulation, and then the ones that are just for the human get applied at this point. Now, what we talked about was taking and making some of these fields private. This is going to break everything. But in the interest of encapsulation and being realistic, this is how classes that are going to be used by other people are written, so that they can't mess with it, so they can't break it. Anything that happens, I'm going to do it. Say hey doesn't make sense to be private. Let's do it anyway, and let's use it from another class. Okay, so now we try to run this, it'll just blow up all over the place. It's really mad because all these are private. Is not visible, is not visible, okay? Is not visible. So we are going to need to use, this will still work. We can pass in our method, our variables to our constructor, and it will still be able to set these. What's blowing up down here is where I'm trying to access them from client code, mrharding.age. That's not going to work anymore. Let's get rid of that. Say hey is not going to work anymore because it's private. Trying to set mrharding.charming equal to true, no, that's not going to work because it's private. So no, you can't do that. So what if we did want to get my age and say Mr. Harding is however years old? We're going to have to go up and do the human class and do a getter for age. No problem, we do this all the time. So public int, because it's going to return an integer, get age. Don't need an argument because it's talking about this instance. We're just going to return age. Look at that, we're done. We just made a getter. So now over here in our client code, all we have to do is instead of accessing that field directly, we just make this get age. Is this going to work? I don't know. Let's see. It's mad at us. Why is it mad? Cannot be resolved or is not a field. Oh yeah, it's a method. You need a parameter list. Don't be stupid. There we go. Hey, look at that. Mr. Harding's 54 years old. Awesome. Okay, so we want Mr. Harding to say hey. Well, I made say hey private. That is never going to work. Say hey is not ever going to work because it's private. But we may have some other method that can use say hey to output something. So we might have a, this is a getter. We might have a method that says, is he a good, let's see, well, that's, why would a human say hey? How's it going? Is that going to work? We have a public method called how's it going? Oh, it needs a return type of void because it's not going to return anything. And it's going to call say hey from in here. Say hey is private, so this should work, right? So let's go to our client code. And Mr. Harding, how's it going? Hey. Well, why does that work? How's it going is public. It is a member of it is a method of the human class. Teacher extends human, so it gets a copy of everything that's up here. Can't access say hey directly. It can access how's it going directly, and how's it going calls say hey. Now, in teacher, which is the child class, we can't call super say hey. I mean, we could try. So we can. You remember the super keyword can access things in the superclass. Let's see if this works. You think it will? I don't, especially not if I type it like that. Oh, well, it's not happy about something else. What's going on? Human teacher. Why is it mad? Syntax error. Unresolved compilation. That's in teacher. Init. Inheritance review command line 13. What? What did I mess up? Oh, because there is no, yeah, there's no main because this is a class. So we're going to need to create a method, call that method from the client code. The method is going to try to call the superclass code. So public, so we can call it from the object itself. Let's call this, let's just call this one, say, human hey. Okay, that's what I meant to do. And it needs a return type. Yes, thank you, Java. Yeah, it's not visible. So there's the answer. We're going to get an error. I don't call it actually from my client code. So let's try. Say human hey. Try to run it, it's going to blow up. Say hey from the type human is not visible. And that's in the teacher say human hey. So teacher Java line 20, teacher.human say hey. The error is say hey from the type human is not visible. So teacher is the child class. This method is fine. It calls it just fine. It works super. Haha, super. But it does not have visibility to the superclass's say hey method because it's private. Or no, I take it back. It's public. Doesn't have access to it. Why not? Oh, because it is private. My bad. It's right here. We could call the how's it going. So that works. So we've done both. From here, we called Mr. Harding how's it going, which says, where is there a method called how's it going? Is it in teacher? No. Is it in human? Yes. So it calls this. And it does say hey, which is private. Then in the next line, we call Mr. Harding's say human hey. Is that in the class which we are instantiated from? Yes, it is. It calls the superclass public method called how's it going. So it goes up to the superclass, it says how's it going. Yep, it's public, it's going to work, and it calls the private method. That's a really contrived example, just showing how the visibility of these things works. If they're public, you can reach up and use them using the super keyword like this. If they're private, even if they're in the class from which you were derived, you cannot. So We'll make this private. Humans say, hey, it's right there in teacher, which is the actual class that Mr. Harding is derived from. Doesn't work because it's private. That's something that, again, I lied to some of you about today, and I feel bad about that. But sorry, trying to make amends. Okay. So again, now the next thing I was going to talk about is these private methods. We have a private method up here. We use it in a public method. Yeah, that was what I was going to talk about. And this is a contrived example, but if you had a lot of complex code up here, you might have methods in here that do math, that do some fancy math, that you don't want your client code just running them explicitly. You might want to ask it some question, and this method, which is public, could call a bunch of private methods to do the calculations and get the answer and send it back. Just as another contrived example. What else was I going to talk about? So you need to have accessors and mutators. So a mutator, these are getters or accessors. I'll make one. And then these are just methods. So a setter. Let's set the hair color. Say my hair color changed. So public, it has to be public so we can use it. Void, it's not, well, it could return the actual hair color, but it doesn't have to. Let's just make it void for now. And we're going to need a string new color. And then all we're going to do is set the hair color equal the new color. Bang. Now, we could do it. We could do a, well, let's just do it. Sorry, we'll just do it first. So from the client code, Mr. Harding set change hair color, not set hair color. Okay, so if I set my hair color to black, does this still work? Yeah, it seems to. Uh-oh. Now what am I going to do? Remember when I returned void? That was dumb. But, well, let's just use a getter. Let's create a getter for the hair color. Return hair color. Simple, easy, done. So then down here we can do Mr. Harding has plus Mr. Harding dot get hair color. So now I have black hair. We take this exact same thing. Let's move it up here. Run it again, and it says Mr. Harding has gray hair. He's 54. Hey, hey. Mr. Harding has black hair. Because we changed my hair color to black using the setter, change hair color, or the mutator. Now, when I was talking about class invariance, let's say that, oh shoot, I closed human. Human's hair can only be certain colors. So we're going to take our mutator and make sure that we can only set the hair to be black, gray, or blonde. This is going to be kind of a complex logical expression. Or and this is not going to take into account capitalization. This is really bad code, but it shows you what you can do. No redheads are allowed. Otherwise, this is not a proper error handling, but it doesn't change the hair color. You'll see if it's one of these, it will change it. Otherwise, it will not. It will simply just print this and return. So it works fine because I put black in here. But I'm going to try to make myself a redhead, and it's going to say, no, I don't think so. I still have gray hair because I tried to change it to red, and it said, nah, it must be black, blonde, or gray. This is a class invariant, not a fancy one, but it is a class invariant. It says the only way you can get to hair color, because it's private, is through this mutator, this setter, change hair color. The only colors it will accept are gray, black, and blonde, because it doesn't like redheads. Or brunette, I guess, whatever other colors you want to come up with. It's also going to be really stupid and picky, and it's going to complain if you do gray as well, because it has to be case matched as well. That's fine. So I think we've talked about everything I wanted to talk about in my list here. Private superclass methods, we do have that one up here in human. We have the private method that was called say hey, and it just prints out hey. We can't call that from anywhere else except inside this class, and we did from this public method called how's it going. Accessing the superclass constructor we did. Let's see, private superclass fields. Why you would want them? It provides encapsulation. You need to have accessors and mutators if you're going to have private classes and actually use them. I don't have a full set of accessors and mutators for either of these, but I have a few just to show how they work. A couple accessors and a mutator with a class invariant. In database language, you'd call this a constraint. What else? I think that's probably about it. Opportunity for class invariants, private superclass methods. Okay, so then next time we'll talk about overloading and overriding methods. We'll use the same example probably. Why not?